Now in this video we're going to look at an example where we approximate the area under the surface z equals 16 minus x squared minus 2y squared over the rectangular region 0 to 2 by 0 to 2. And as a reminder, this notation for r means that x goes from 0 to 2, it's a closed interval 0 to 2, and also y goes from 0 to 2. So in the picture here we see a visualization of the surface. It looks like a dome shape, and then down in the xy plane we have a rectangular patch 0 to 2, 0 to 2. And what we're going to do is we take all those points in the rectangular patch R and we apply the function, so we get up there onto the curvy surface, and what we're really interested in is what is the volume under the surface and over rectangular region R. So I've discretized region R over here. We've got the xy axes and we've divided up this region into 4 little squares. Each of them are 1 by 1. And the area of each of these squares is 1. We'll call that delta A equals 1. So now we need to figure out what is the height of this rectangular prism. For example, region R11 is down here in the xy plane, and sitting up above it is some rectangular prism with a given height. So I'm going to choose any point in rectangle R11, and I happen to just choose that upper right hand corner with coordinates xy equals 1, 1. So I'm going to take that xy pair 1, 1 and I'm going to apply it into my formula. So I've got z equals 16 minus 1 squared minus 2 times 1 squared, and that works out to be 13. So the height of this first rectangular prism is 13. Okay, now we've got 3 more rectangular prisms to draw, and again I'm going to choose the evaluation point to be that upper right hand corner of each of those patches. And when we do that, we get these little rectangular prisms with height 13, the first one we did, and then we'll get a height 10, another height 7, and a height 4. So to approximate the volume, we will do height times delta A, so 13 times 1 plus 10 times 1 plus 7 times 1 plus 4 times 1, and that equals 34. Now, another strategy you can use here is sometimes using geometric formulas to find the double integral over r of f of xy dA. So here's an example. If r equals the set of xy points where x is between -1 and 1 and y is between -2 and 2, let's evaluate the double integral over r of the square root of 1 minus x squared dA. So let's take a look at this integrand. We have z equals f of xy. So our multivariable function really here is the square root of 1 minus x squared. Now keep in mind we are working in 3 dimensions, x, y, and z, and so what this tells us is that z squared equals 1 minus x squared. And this turns out to be a cylinder. Turns out to be a cylinder where the base looks like a circle, x squared plus z squared equals 1, and that's in the xz plane, and then the y coordinate runs wild. All right. Now, since we're only looking at the positive root, we're actually talking about a half cylinder. So let's draw a picture of what we're looking at, and then we can use a geometric formula to solve this. So here we have our x, y, z coordinate system. X goes from -1 to 1, so we'll come out 1, and then the x-axis goes back into the page, so we'll go -1 back in there. Y goes from -2 to 2. So our y-axis runs horizontal here, and we'll go out to 2, and then the other side here we'll go over to -2. So now let's figure out this cylinder. This cylinder is x squared plus z squared equals 1. And that looks like a circle in the xz plane. Let's correct that right there. There we go. And in that xz plane, we've got that circle of radius 1. Y runs wild. Y is unconstrained, at least in terms of the formula. We know it only goes from -2 to 2. So there's our cylinder, and here's the top half of the cylinder that we're actually really interested in for this problem. Okay, so let's pull off that half cylinder just to take a look at it. It's got that semicircular end, and then goes from -2 to 2 in the y direction. Now we know the volume of a cylinder, right? We know the volume, and so we know in this particular example the radius is 1. So let's compute this. The length is negative 2 to 2. The length is 4. So the volume of our cylinder, it's base times height, or base times the length. So pi r squared times L. And in this particular case, it would be pi 1 squared times 4, or 4 pi. And so for our half cylinder, the volume of the half cylinder would only be 2 pi.